In this video, we will get an introduction to exploring quantitative data in R, and we'll focus on a visual summary called a histogram. There's a lot more analysis you can do with quantitative data. For a further treatment of exploring quantitative data in R, you can go to this link over here in this notebook. If you want a recap of how we explored categorical data, there's a link over here. You might be wondering, how can you get these links? And here's a link to this Colab notebook that everybody can get access to. I'll put a link in the description of this video. And so once you open up this worksheet, you can go ahead and click on these links if you want to see some additional information. But we'll be working with the storms data frame and the dplyr package in R. And in particular, we'll be focusing on getting a graphical summary of the variable wind, which is a numeric variable, which is measuring the wind speed of each storm in that observation in the data set in knots. Step one is to load the dplyr package into this session in R. So I've just started a new session in R. I don't have dplyr loaded yet. So I'm going to run the library command to load the dplyr package. This message down below is not an error. This is not a crash message. We've worked with this package before, so hopefully you're familiar with this sort of message. We can ignore it. dplyr has been loaded just fine. Here is a summary of some commands that we've previously used when exploring the data sets in R. So we've seen things like the help manual and summary and head and tails. There's a function called glimpse that is actually part of the dplyr package. So if you haven't loaded the dplyr package, this command won't work for you. But we've loaded the dplyr package. So if I do a glimpse of storms, this is essentially looking the same as what the structure command does, the str command does. You can see they're almost identical. This command over here does not need any package. This is in base R glimpse. Maybe the formatting is a little bit cleaner to read up here. But again, we're working with the wind variable, and this is a numeric variable, and it's measuring the wind speed of each storm in terms of knots. And so a very natural question might be, well, how are the wind speeds distributed? Are most of the wind speeds small or most of the wind speeds big? How are they distributed between the maximum and the minimum values? And that's exactly what a graphical representation should help us analyze. So a very common graphical representation that we can use to summarize quantitative data is called a histogram. And so a histogram is a type of bar chart. It's a very special bar chart that's used when we want to display the distribution of a quantitative variable. So in R, there's a nice built-in function to create histograms that's called hist. So we just need to load up a vector of numerical data. We can add some options to make the histogram a little bit cleaner, and out will pop a histogram. So I'll just create a histogram down here for the wind variable in storm. So remember the convention that we first write the data set name followed by a $, and then we can pull off one variable at a time by indicating the variable name. So this will create a histogram of the wind speeds of all of the storms in the storms data set. And we can infer a bunch of information from this. We'll talk about that in a second. But what's important to note is how a histogram is created is it's going to take the range of values from the minimum wind speed up to the maximum wind speed, and it's going to create a bunch of different bins, each of equal width. So for example, there might be a bin that goes from 0 to 10, and then another bin that goes from 10 to 20, and so on. And each of these bins should be the same width. We don't want one bin to be twice as large as another, because then the heights of those bars, how we interpret them, might be misleading. The bins don't overlap, so each value in our data set, each observation, should be placed into exactly one bin range. And the ordering of the bins is very important. So this is like an ordinal, it's numeric. So we want bin 0 to 10 to be on the left, and then 10 to 20, the next one, and so on. And then how we can read these histograms is the height of each bar tells us the frequency or the number of observations in each bit. So if we zoom in on this histogram a little bit, over here we can see the first bin seems to have about 1,000 values. But what might not be so clear in this histogram, the axis kind of starts over here. We don't have any necessarily nice naming, so this is where some of the options for working with the histogram function come in hand. And so we'll talk about those options shortly, but you can always run the $hist command to open up the help documentation, and that explains all of the various options that are available to use in the histogram function. So before we take a look at those options, I want to let's take a look at what happens if I run this command storm's status. So remember, the status variable is a categorical variable, which is like, is this a tropical storm or a hurricane or so on. So if I try and create a histogram with categorical data, I get an error message here saying that X, which is what I entered into this histogram, must be a numeric variable. So histograms, they only make sense if we're working with quantitative data. If we have categorical data, we would not use a histogram. There are some other plotting functions in R that we've seen. The most kind of generic plotting function in R is just the plot function. And this could work well with categorical data. If I do plot storm's status, notice that it created a pretty reasonable looking bar plot here. We could change the coloring and things like that if we wanted to, but this plot function was able to recognize that status is a factor. It's being stored as a factor. So a reasonable plot for categorical data is a bar plot. If I try plot storm's wind, I get an index plot over here. The wind variable is being stored as an integer numeric, and the default plot that R is coming up with is maybe not the most helpful plot. So we really want to use a histogram, and we'll see box plots as well as nice ways to summarize quantitative data. So down below, I've got, I'm going to make the same plot, a histogram of the wind speeds, and now I'm using a whole bunch of different options here. So I'll let you kind of read through the options on your own, but what I do want to point out is all of these comments over here, these are comments that I see in green. So this is not actually code that R is going to execute. So anytime I put the pound symbol over here, or the hashtag symbol, anything that comes after that symbol is read as a comment, meaning it is on the screen, we can read it, but it's not actual code that's going to be executed. So people use the hashtag comment as a nice way of explaining what code is doing so that others who read your code can follow along. So here you can see I've cleaned up the histogram a bit. I changed the color. Some things are a little more superficial, like the color, but I certainly cleaned up the axes a little bit and cleaned up some of the labels on the histogram. And so now that I've got this histogram, let me just stop to interpret what I'm looking at. And so what I can see just generally from the shape of this data is that most of the observations in this data set were storms that were not very strong, that had wind speeds, say, less than 50 knots. But we do see this tail kind of pulling off to the right. That's indicating we do have some outliers on the far right that had really high wind speeds compared to like what a typical storm in this data set is. So when we have a data set with such a shape, meaning most of the values are on the left, and we've got a tail of outliers on the right, we say that this data is skewed to the right. And we can also get more specific information. For example, question 5, you might be wondering, why are we starting with question 5? And this just ties into the course materials that we'll be working with in class. So question 5 on that worksheet is asking us to count up approximately how many storms have a wind speed less than or equal to 40 knots. So let me zoom in on this just slightly. And so the first bin, 0 to 10 knots, that is empty. So we don't have any observations there. This next bin is going from 10 up to and including 20 knots. And I can approximate that as about 1,000 observations had a wind speed between 10 and 20 knots. Between 10 and 30 knots, I'm going to approximate this as about 4,800. Between 30 and 40 knots, I'm going to approximate this as about 3,500. And if we add up the heights of those three bars, the 10 to 20, 20 to 30, and 30 to 40, we get a total of 9,300 storm observations that had a wind speed less than or equal to 40 knots. Okay, so before we take a look at another example, I want to just explore one of the options that we have when we create histograms a little more carefully, and that's the breaks option. Since some of these options are a little more superficial, like the color, but changing the number of breaks that a histogram has, the number of bins that we use, can have a substantial effect on what we can infer. So for example, here is a histogram. It's essentially the same exact histogram we created above, but I'm only going to use 5 breaks. And so notice from those 5 breaks, one thing to note is we have 1, 2, 3, 4 different bin ranges, since it counts the first break over here, then the second, the third, the fourth, and the 5th break. So the number of breaks that we have means the number of bins is going to be 1 less than the number of breaks. And so by setting this to just having 4 different bin ranges, we can't get very specific about the distribution. Setting it to 50, we get a more kind of accurate description of the data, but it's hard to read each of these individual bars. So there's kind of like the Goldilocks zone of getting just the right amount of breaks to make your histogram, pop the best. So you can always experiment with the breaks to get a histogram that looks best for you. For example, before we stop this video, and then the question 9 is something that you'll work on before class, is let's say we want to create a histogram to display the variable month, which is also a quantitative variable. So I'm going to say hist, and then the data set is storms. I put my $, and now the variable name is month. And let's see what comes out. So again, I haven't kind of messed around with too many of the options here, but this looks kind of weird, right? We have all these empty spots in between, and really when it comes to month, this really shouldn't be an arbitrary number of breaks. We probably want to see how many storms occurred in each individual month. So that means we want 12 different bin ranges. So we include the start of the first bin as a break and the end of the last bin as a break. So that means if we want 12 bins, we have 13 breaks. And now this looks like a more reasonable plot to read. This first bin over here corresponds to the month 2, so this would be February, and then we have March, April, etc., all the way down to December. And this histogram, we would say, is skewed to the left, in the other direction. The tail of outliers is on the left here. So most of the storm observations occurred, you can kind of see like in the late summer, in the early fall, on the right side of this distribution. And it was not very common at all for a storm to occur in the first couple months of the year. And so that's why these would be outliers. And this shape of this distribution, we would say again, is skewed to the left. Okay, so the last question about the distribution of longitude values, that's something for you to explore and come to class, and we'll hit the ground running with some additional exploring of quantitative data.